So now we'll find the position of bright fringes and dark fringes. So we know at a distance x from the center of the screen, the path difference is given by xt by t. Now if at that point a bright fringe is formed, that is due to constructive interference, then we can write that due to constructive interference, if a bright fringe is formed at P, then that path difference, which is xt by t, will be equal to m lambda. We already know this condition because for constructive interference, path difference is equal to m lambda, where lambda is the wavelength of the source, right? Or x is equals to m lambda capital D by small d, where m has these values 0, 1, 2, 3, etc. Okay. So now if we put various values of m, we will get the various positions of the bright fringes. Okay. So the positions of bright fringes will be, so at first for m equals to 0, x0 is 0, which gives us the central bright fringe. That is at the center of the screen, which is at C, a bright fringe is formed. Then for m equals to 1, we get the first bright fringe at a distance lambda d by t. Okay, so first bright fringe on either side of central fringe. Okay, then for m equals to 2, we get the second bright fringe, which is at a distance, formed at a distance x2 equals to 2 lambda d by d, which is the second bright fringe again formed at a distance x2 equals to 2 lambda by d on either side of central fringe. Okay, so in this way, for m equals to m, we get the mth bright fringe, which is m lambda by d, which gives us the mth bright fringe. Okay, so in this way we can also find the position of the dark fringe. Only the condition for the dark fringe now it will be different. So similar to bright fringe, due to destructive interference, if a dark fringe is formed at point P, then the path difference xt small d by capital D will be equals to 2m plus 1 into lambda by 2. We know this, right? So x will be equal to 2m plus 1 lambda d by 2 capital D, where m again has these values 0, 1, 2, 3, etc. So what will be the first position of the various dark fringes? So positions of various dark fringes are, so for m equals to 0, we get the first dark fringe, suppose at position x1 prime, which is lambda d by 2t. Okay, formed. So this is the first dark fringe formed on either side of the center. Okay, then if we look at the center of the screen, here a bright fringe is formed. Then on either side at a distance of x1 prime and x1 prime, a dark fringe is formed. Okay, so it will be like this. So here suppose, so this is the setup, S1, S2, this is the center. Suppose this is the position, this one is x1 prime and this distance is also x1 prime. This is the central bright fringe. Okay, and on the either side of the central bright fringe, over here and over here, okay, the first dark fringe will form. Then again there will be a bright fringe, then again dark fringe. So in this way we will have alternate dark and bright fringes. Now for m equals to 1, we will get the second dark fringe x2 prime, which will be 3 lambda d by 2d. Okay, this is the second dark fringe. Then again for m equals to 2, we will get the third dark fringe, which will be 5 lambda d by 2d. It will give us the third dark fringe. So in this way, so you see, for m equals to 0, we will get the first dark fringe. For m equals to 1, we get the second dark fringe. For m equals to 2, we get the third dark fringe. So to get the mth dark fringe, we have to put 1 less than m, which is m minus 1. We get the mth dark fringe, which will be formed at 2m plus 1 into lambda d by 2d. Okay. Which will be formed at 2m minus 1 lambda d by 2d. Okay. So this will give us the mth dark fringe. Okay. So now what we'll find? We'll find the fringe width, which is the separation between two successive bright fringes or two successive dark fringes. Okay. So next we'll find our expression for fringe width. So what will be the fringe width? It is the separation between two successive bright or dark fringes. Okay. So what is the width of the bright fringe? So width of a bright fringe is the separation between two consecutive bright fringes, which is, suppose we take the mth bright fringe minus m minus 1th bright fringe. So what is the position of mth bright fringe? It is m lambda d by d minus m minus 1 lambda d by d. So it will be lambda d by d. Okay. So similarly, what will be width of a dark fringe? So width of a dark fringe will be separation between two consecutive dark fringes. So suppose again we take the mth dark fringe minus xm minus 1 prime, which is the m minus 1th direct fringe. Okay, so the direct fringe is given denoted by a prime. Okay, so the position of the mth direct fringe is 2m minus 1 lambda d by d minus the position of m minus 1th direct fringe will be, in place of m we have to write m minus 1, then minus 1, this minus 1 lambda d by d equals to lambda d by d. Okay, so now you see clearly the width of a bright fringe is equals to lambda d by d, and width of a dark fringe is also lambda d by d. So it means that both the bright fringe and dark fringe have equal width. So it is clear that width of a bright fringe is equal to width of a dark fringe equals to lambda d by d. Okay, so which is so width of interference fringe, whether dark or bright, is denoted by beta, which is given by lambda d by d. Okay, so you see it is independent of order of the fringe, that is m, independent of m. So all the fringes, irrespective of their order, have equal width. Okay, so the dark fringe and all the bright fringes, whether they are of zero order, the central bright fringe, or the mth order bright fringe, or the third or fourth order bright fringe, all of them have equal width. Similarly, all the dark fringes also have equal width. Okay, which is equals to lambda d by d. So now, if the separation between, if d and d are kept fixed, then you see beta is proportional to lambda. Okay, so the fringe width depends on the wavelength of the monochromatic light we are using. So if you are using, so we know the wavelength of red light is greater than wavelength of violet. Okay, so if you are using red light as our source, then the fringe width will be greater than fringe width due to violet light. Okay, now we see another thing is that here where we find the position of the dark fringes. So here you see we have to make one correction, that it will be lambda capital D by small d. Okay, so here capital D by small d. Okay, so the fringe width is given by beta equals to lambda d by capital D. So if we know the wavelength of the monochromatic source, the separation between slit and the screen, and the slit separation small d, we can find the fringe width of any interference pattern.